Well, hi, good morning, and thank you so much for joining me here in my shop. Today is April 27th. I'm ready for the second step with this radio. Yesterday, discovered the tubes were in pretty good shape, and the radio essentially works. It's just really, really weak, and it has some entrails hanging out of it here. And I think I'm going to clean all this up today, get rid of these big capacitors. There's 3 of them here. Tidy this up so it's a little neater looking, give it a test and make sure it's still working after I change these, and we'll see how it works at that point. I don't expect it to work really any differently than it does now, in fact, because it's hum free, and surely it's hum free. Look at all these capacitors in here, holy smokes. just a ton here of capacitors. Now, why he's got this many in here, I'm not exactly sure. If I look at this one to start with, I see the black lead going down to a terminal, which essentially is the side of the original capacitor can, which is also insulated. I can see a piece of material, non-conductive material in here. The capacitor is insulated from the chassis. And you can see it here also. If you look, you can see the rivets holding a non-metallic material. I don't know what it is exactly. Brown material down here, and the capacitor is mounted to the brown material. So no connection. Underneath this cardboard is a metal can, and one of the reasons it's got cardboard on it is so you can't touch the metal can anywhere. So that's what they've used. They simply use that terminal, which is quite fine. So that's an easy connection. This capacitor's got the same thing, same black wire going to the same spot. Now, what's going on with the red wire from this one goes here, and there's a red wire going back to one of the original terminals, which is down here. And the yellow one goes to the other terminal. If you notice, can you see this in the camera? Yes, a big resistor right here. So you have 2 terminals on the capacitor, and the resistors connected in between. So the terminals have been cut, so the whole thing's floating now. The resistor's kind of floating in here. Okay, floating a little bit anyway. So this guy is connected up just as I would imagine. He's absolutely replacing the original one. Now, what about this guy? What's he doing in there? So black wire goes there, and he's got 3 wires on the top. 2 red and a yellow. So the 2 red are going the same 2 places, either side of this big resistor. And the yellow, now the yellow, here it is, way down here. So they have the 2 reds, and they put the yellow one way down here. 25 microfarads, 25 volts. So the yellow is the bypass. Now, I thought this green one would be augmenting the bypass. This is the cathode bypass capacitor for the output tube, cathode resistor. And what's this guy doing? So we got the positive just hooked up to one side of the big resistor, and the negative hooked up to this. It appears to be hooked up to this tube. It's hooked up to a terminal on this tube. What is that tube? That tube's the detector tube. What's this great big capacitor doing hooked up to a terminal on the detector tube? Now, just maybe this is a negative. Maybe, yeah, you know what? I can see it. Make sure I'm not getting confused by the wires. There's a black wire running from this terminal back to this main negative thing. So this is just another place to hook up the negative side of this capacitor. So this one was just hooked up to the far side of this resistor too. So on the far side of this resistor, this radio has a 40, a 40, and a 40 hooked up in parallel. So that's 120, and almost certainly the capacitor on the top is a 40, like the original is a 40. So the only way I can rationalize what has happened here is the fellow who did this, the woman or the fellow who did this, thought his 2 capacitors he was putting in were questionable. So he put 2 in parallel, hoping that they would be enough and then for some reason he threw a third one in. Boy, oh boy. That's a heaping load of capacitance. No wonder this radio doesn't hum. So nothing surprising happening here, except maybe one thing. This bypass connection. This guy's all alone here. He didn't super augment the bypass. He's relying on the 25 in here. Yeah, it goes right down to the output tube here. He left this just kind of floating here too. Okay, any reason to preserve these old capacitors? Any reason to maintain the wire positions? No. No. What else can I just cut away here? I hope I got it right. Negatives. I'm going to leave some of this negative wire on here. I'll leave it all on here for now. Okay, there's those guys gone. Hey, that looks a lot better already. This guy, any reason to keep him here? I don't think so. Right off. And I'll nip him off here. Micromite electrolytic, made in England. May 1951. So for this to be in a radio that has 1953 written on the back of it, this is somebody's junk box capacitor, maybe in 1965 or somewhere around there, pulling this out, sticking it in. Could very well be the same of these. We're going to find any dates on these. Plessy, UK. That's the second one from the United Kingdom. There's the date on it. March 1964. Isn't that interesting? 1964. So that does add up. That's just what I said, wasn't it? Sometime in the early 60s, didn't I say that? And again, there's going to be no date on this. Well, it's got 452 on it. I think that means April 1952. Okay, so it's just going to be a couple of small capacitors to replace these. Now, what about and the bypass? They take 3 capacitors to replace what was in there. Okay, so I'm going to work away at that and get that done at my leisure, and then I'll carry on the video. We'll test the radio once I get it all ready to go. Okay, first capacitor in. Can you even find it in there? It's that little yellow one right here. So that's replacing the 25 microfarad 25 volt one. This is a 30 microfarad 50 volt capacitor here, which I tested, which is good. Okay, so I just have these two to go in. We're ready to operate again. Okay, so I'm spending lots of time outside here between these little sessions where you see me in my shop working outside in the beautiful sunshine. Cannot miss the opportunity to be in the sunshine. So what I'm doing is I'm connecting the 2 negatives of these 2 50 microfarad capacitors. I'm connecting the negatives together here to one big negative. Okay. And what I'll do, my plan is up here. So the big resistor there, the terminals are on either side of this big resistor. So I just want this 2 positives to connect, kind of like that, and the negative to go either on the wire, or maybe I can get it right down on the terminal here. Clearly I don't need these 2 black wires here, so we'll get rid of one. So this has a little bit of weight to it. a little bit of mass to it. So if you put it in a radio like this and you leave it really floppy like the other ones were, they can potentially move around a little more than you might expect, particularly if, for instance, the radio is thrown down a flight of stairs. That would probably cause the floppy capacitor to move into some bad position. So you want to put these in some way that they're a little bit rigid. So in fact, soldering this right to that terminal would do the job. Hey, that would be a good idea. If I can get it right down on the terminal there. So I think the next thing is to clear off these taped up terminals. We'll see what was done underneath. I'm pretty sure this all got soldered. It would be a nightmare if it wasn't. No, it's all soldered up. The terminal from the capacitor is way up here now. That's good. And this here. I don't really like using the tape in a radio like this. This tape doesn't have a very long life, as it turns out, compared to other things anyway. So there's the two terminals. This will stiffen this up too a little bit. This is a little floppy here. If I can get this mounted right down on there. Yeah, just like that. I see it. I do see it. So, without mentioning the name of the thing that's running around the whole world right now, I don't want to mention the word on my video. I will talk about it just a little bit. I think about it like a big airplane. The thing that's troubling us all right now, whose name I cannot say, it's like an airplane. It's like an airplane in your country, takes off and starts flying up. The numbers get bigger and bigger and bigger and bigger. Eventually, so many people, it starts coming down again. Down, down, down. Somewhere when it gets down on the ground, it's safe to get out of the plane again and go about our lives until the plane takes off again. In the case of the country south of me here, the plane is flying really high right now. Maximum number of people getting on that plane every day. I mean, it's a bit of a bad explanation, isn't it? How do you get on a plane flying in the air? 30,000 people getting on the seaplane every day right now, more than ever in the country south of me. The plane is flying higher than it's ever flown. The doors are being opened and people are getting out of the airplane instead of waiting for it to come down, back down to the ground. You know, it's so obvious to me that a big mistake is being made, but millions of people are making this mistake. It's really hard to understand. Really, really, really hard to understand. That's how I view it, though. That's what makes it really obvious to me. The Canadian plane is high in the air right now, too. And but the Canadian attitude for Canadians, as I understand it, is just like mine. This is no time to get out of the airplane. We got to get this plane close to the ground before we start getting out of it. There. You know what? This is going to work quite well. If I can just solder that in there. Now, of course, each one of us is flying our own plane. Really, aren't we? We're making our own decisions about what to do every day. Where to go, where not to go. Because I watched that airplane crashing show, Mayday, I know that even the best trained pilots, with all the best opportunity, still make mistakes and get killed because of it. Okay, let's just bring this one around here. What's this piece here? Get this out of here. The problem, it's the same problem for us as it is for a pilot. These decisions we're making every day, go to the grocery store, not go to the grocery store, wear a mask, not wear a mask. What's at stake is our lives. This is no casual thing, like a pilot. There's no tolerance for making a mistake. You don't get a second chance. If you get sick, the dice roll. Are you going to make it or are you not? The dice are rolling. I don't want to roll the dice on my life. Yeah, okay, enough of that talk. I'm doing this to try to hide away from all that stuff. You are too. Got a little big blob of solder there. There it goes. Some of that tape glue is left on it. I think I got it. We'll check it. Yep. Now this one. Got a bunch of stuff here. It doesn't need to be hanging out of here. Wasn't soldered on. A little bit of this stuff here. This stuff. Are you old enough to remember Jim Jones? Jim Jones, a man who convinced over 1,000 people to just kill themselves? Doesn't that sound impossible? How do you get 1,000 people to just agree to kill themselves? How do you make that happen? Not just themselves, but their children, and just, you really get people to do just utterly horrible things. I think part of the secret to getting people to do horrible things is to get them to stop thinking for themselves. That's the first thing. I think that human nature is actually very, very kind, I believe. Very kind, oriented to sharing, all that kind of stuff. I think that's what a real human is like. Obviously, the success of humans on this planet comes from working together. That's really obvious. Really, really obvious. Okay. Now, I shouldn't be talking about that stuff, but camera's rolling and I'm just soldering stuff, so my brain is free. Now, oh, this didn't get on. Let's check the other one. How did I check that and convince myself it was okay? The other one's on. This one missed entirely. Let's put it like this. I was suspicious. Oh. There. Good. This is not going to go any distance here. There's nothing to worry about in terms of flopping around. Even though these terminals are sitting here, there's lots of other terminals exposed there to touch and get shocks or whatever. So I'm not going to put tape in there. I think that's much better that way. I think we got it. I think we're at the point now where it's testing time. This one can move and short up there. That's for sure. This little guy here. not so. Okay, I think it's good. I think it's good enough. Good enough. Okay, there we go. Hey, the guts aren't falling out anymore. They've gutted this radio here. Okay, now. Okay, dim bulbs. All eyes on the dim bulbs. I've done capacitors in the power supply. There's a percentage where I get these backwards. I don't think I got these ones backwards, but there is a percentage that I get backwards. Okay, switch is off. Plug is in. Dim lights on. Power on. Nothing happening. Perfect. 124 volts today. We'll switch on here. Okay, so a little disappointed. I really expected this bulb to come on. Okay, so the tube's lighting up. Well, maybe taking all this out of there, taking all these out, maybe I've reduced the capacitance. Listen to the thing hum. Oh my God, what's happened? So now that hum, that could be from other capacitor problems in the set, so I'm not going to freak out over that. Some of you might be saying you got to replace this light because the light is involved in the heater circuit. True, but it's not absolutely critical. So I'll put a new one in here soon, as soon as I remember. Well, what do we get? That's full volume, so we still have low volume. Okay, so I'm going to put a booster up here, antenna booster. Okay, so this looks like a lot of stuff. It's really not. It's just an old chassis with a radio antenna on the back of it here. So it's a two-part antenna. It's two coils. There's one or two turns, and then the rest is the other part. The other part, the main part of this, is simply paralleled with this capacitor. So you tune this capacitor, you tune a resonant frequency with this coil that is within the AM radio band. The smaller coil, the one or two turns here, I have hooked up. I'm going to hook it up to an outdoor antenna. That's what I'm doing here. I have to go throw a switch though to make this completely work. So my outdoor antenna is energizing the couple of turns here, and then this outer part is going to be resonant when I tune it with this. This makes this whole thing ring like a bell and produce a strong field around it, which I can then dip the radio antenna into it. And then this radio will pick up what this one is boosting. Well, I got to turn a switch to turn on the antenna leads here. I'll just be gone for about 12.34 seconds. So now, looking at the tuning here, I'm just going to slide this back. We want the two antennas to be fairly close. Around here. See, this radio is tuned around 640. I know there's a station there. So I'm going to tune the antenna. You can see my hand back here. Bring it into closer proximity. Can't get much closer. don't need much boost. So the distortion we're hearing could be from the speaker. The speaker has a big tear in it. That's unfortunate. See if we can figure it out. So what I'm doing there is I'm trying to tip the cone a little bit so as to swing the voice coil back and forth a touch in the slot that the voice coil is in the magnet. The idea is the voice coil is rubbing on one edge, and if you can move it a bit by pushing this and release it from where it's rubbing, you would immediately hear an improvement in the speaker. I mean, you'd know that was happening. I tried these different corners best I could. I could hear no change. The other thing is when if you're like the lock-picking lawyer and you've got sensitive fingers, you can push on the cone and you can feel it and hear it rubbing. There's nothing happening like that. There's just no evidence that the speaker is causing the distortion we're hearing. So, interestingly enough, the distortion is very much related to the position of the volume control. So you turn the volume control, of course, you're varying a resistance, and that's varying the way a circuit is operating in the radio. So boy, that would point right to that area as being maybe where this distortion is coming from. Let me just turn it up again. So it sounds like a tube is operating way out on its bias, or maybe the B plus is super low or something like that, causing that sort of choppy kind of sound, like something is being limited in the radio. Okay, no surprise in any of this. Let's turn it off. The main thing was, is it still working? Yes. Is it working any different? I don't really think so. I think it's working exactly as it was. So from here, it's all about these old capacitors, of which there are quite a few in here. Quite a few. Considering the distortion and the volume control effect, maybe we'll start with the audio capacitors, which offhand are these guys down here, down around the output tube and that. Oh, that's pretty warm. So this might be the bypass resistor for the output tube. It's a large wattage one. Okay. I don't think there's any more to... I think I'm ready. Ready to go outside and enjoy some more outdoor activities right now. So thanks a lot for watching. And I'll carry on with the rest of the capacitors probably tomorrow. It's too nice a day to stay in here. See ya.